Students, already in the previous video I have explained you about the cofactors of the elements of a square matrix. Now we are going to study about adjoint of a square matrix. Adjoint of a square matrix. Suppose a square matrix A is given Aij of order m cross m. Okay, that is a square matrix of order m cross m. What is adjoint A of this matrix? Is the transpose of matrix of their cofactors. Matrix of the cofactors means what I am saying, if it is your a square matrix of order 3, it is given your a11, a12, a13, a21, a22, a23, a31, a32, a33. This is your square matrix of order 3 cross 3. Now I have taken out what? Each element's cofactor, which I told you in the previous video how we get the each element's cofactor. So what that your this adjoint A will be the cofactor of, you have calculated separately, cap a11, similarly a12, a13. It's you are deleting by this one, you have got the value, that is your a21, a22. Capital A means cofactor of that element, cofactor of that element. Now this cofactor, this is cofactor of that element, then I have calculated this is, and this is your 3 3. Transpose of this matrix. Okay, transpose of this vector means now I need to change row into column. So what is your adjoint of matrix A? Will be the matrix of its cofactor, then you need to transpose it. So what it will be, your a11 row into column. So a12, a13. Then what is your a21, a22, a23. Then what it will come, 31, 32, 33. What that? This is your adjoint of matrix A. Now what is important here, if you want to, one example I can give you. Suppose my A matrix is given yours 1 3 3 1 4 3 1 3 4. Now you want to know about that, what is your adjoint of A. So adjoint A, first I need to calculate what, a11, a12, a13. I am writing transpose order already. Okay, a21, a22, a23, and what is your a31, a32, a33. Okay, so now if even power, directly I am deleting, and I am 4 4 ja 16 minus 3 3 ja 9. What it will be, your 7. a12 means negative. First I am, because in this is some negative, already minus sign I am putting, then I will be doing a12 means what, this element, delete this one, 4 minus 3. What is your 4 minus 3? It's minus 1. a13, it is sum, so positive sign will be coming. This I am doing this one, 3 minus 4. 3 minus 4 is minus 1. So I got the elements, this cofactors. Now 2 1. a21 means deleting this and this. 2 1 means odd, negative sign I need to put first. Okay, a21 delete this one, 4 3 ja 12 minus 3 3 ja 9. So what it is, equal to minus 3. Got? a22 is positive, a22 is positive, you are going to this one, and will be 4 minus 3 1. Then it is negative, 2 3 is negative, delete this one, 3 minus 3 0. Got? Minus 0 means 0 only. Okay, 3 1, 3 1 is what, that your third row, first element, delete, it is positive. This is 3 3 ja 9, 4 3 ja 12, 9 minus 12, it's minus 3. 3 2, 3 2 means deleting this one. Okay, 3 minus 3 0, it's negative, but okay. 3 3, that is your 3 3, delete this one, 4 minus 3, 4 minus 3, it's equal to 1. Okay, so what you got, this adjoint A. Adjoint A of this one, what, directly I am not writing a11, a12, directly I am writing in this order, a11, a12, A transpose order. So it will be 7 minus 1 minus 1, then it is your minus 3 1 0, then it is what, your minus 3 0 1. This is your what, that your adjoint A. 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. This is your adjoint A. Got it? How to calculate adjoint A? Now what is the importance in inverse of a matrix? That is also very important. So if I take the matrix, minus square matrix, and I multiply with its adjoint A, so what it actually I am saying, A is your matrix 3 cross 3, a11, a12, a13, a21, a22, a23. Listen it carefully, a31, a32, a33. And if I multiply it with adjoint A means what, that your transpose of cofactors, which already I told you, don't write a11, a12, transpose manner you are going to write. It is a11, A12, A13 column wise, A21, A22, A23, and then what is your A31, A32, A33. Okay, and now you multiply. You know how to multiply two matrices, row with this column 1. So you are going to see very important criteria is coming. A11 is multiplied with A11, then plus A12 with what? A12 plus A13. It is what your A13. Actually what I told, when the same element are multiplied with the corresponding cofactor, this is nothing else but what? Determinant A. And then you are going to multiply with this elements another, this A11, A21. This is nothing else but 0. Then this, if you are multiplying with this one, elements another row's cofactor also will give you 0. Similarly A21 with A11, 0. But when A21 with A21, this will give you nothing else but determinant. And here also 0. Similarly here 0, here 0, but means actually what you got here determinant A 0 0 0, determinant A 0 0 0, determinant A. This is the matrix. So I can take out what that your, this is a matrix, so whole common determinant A will come. And what left here? Identity matrix I. So what result you got? Actually you got A adjoint A, or you can do like that also. Adjoint A multiplied with A will give you the result determinant A I. This is very important result. Okay, and by this what we conclude, if I determinant A, if I divide here, so you are going to get what? A adjoint A by determinant A is equal to I. This is nothing else but what you are getting. Actually very important, this is what your A, this is A adjoint A by determinant A is equal to I. Means if I say this is another matrix B, A B equal I, whenever multiplication of two matrices is giving identity matrix, B is nothing but the inverse of A. B is nothing but the inverse of A. B equal A inverse. So A inverse is actually what? Adjoint A by determinant A, where determinant A should not equal to 0. Now you understood how, if a square matrix given, how we are going to get A inverse. A inverse is a formula is for A inverse. Very important it is. Matrix 6 mark question will come. I will tell you which kind of question generally comes. This is A inverse is nothing else but what? Adjoint A, which I told you how to calculate adjoint A, divided by determinant A. You know how to evaluate. And determinant A should not be equal to 0. So inverse of any matrix you can find out when determinant A, means we call it A should be non-singular matrix. A should be non-singular matrix. Non-singular matrix means determinant A is not equal to 0. And here one important property comes. A is a singular matrix. A is a singular matrix if determinant A is equal to 0. Means sometimes A is given and one unknown variable is put there. Okay, and they are asking what is the value of this unknown variable, and it is given A is a singular matrix. So you need to keep what? Determinant A equals 0. You will get the value of this one. Okay, one another property also I am discussing with you, that is your determinant of product of two matrices of same order is equal to their product. Determinant A, determinant B. Okay, and one more important property is there similarly, that is your determinant of adjoint A is equal to determinant of A, whatever order of given this A, that is your n minus 1. N minus means if A is matrix of 3 cross 3, so it will be 3 minus 1 2. Determinant A square. This is also for 1 mark question. Very important property it is. Determinant of adjoint A is equal to what that your determinant of this power n minus 1. N is order of the matrix. N is order of the matrix. So by using these all properties you can get A inverse square. And one okay, you practice this much. One next another video I will be sending you for some more questions. Okay, practice A inverse, how we can find out. Okay, thank you students.